Okay, welcome to lesson 10.4, where we will be doing more using of the Pythagorean theorem.
So the converse of the Pythagorean theorem, if the equation a squared plus b squared equals c squared is true for the side lengths of a triangle, then the triangle is a right triangle. So when you learned about the Pythagorean theorem, we talked about how this only works for right triangles. So if you're given all three sides, you could test the theorem and then see if it works. So here's example 1, identifying a right triangle. Tell whether each triangle is a right triangle. So looking at A, the green triangle, you can definitely tell which side is A, which side is B, and which side is C. So you go through the steps, and since you get 81 plus 1600 when you square 9 and 40, and you add those together to get 1681, which is also the square of 41, it is a right triangle. But on B, even though it does look skewed with the angles a little bit, you would definitely always know that the longest side is C. So 12 squared plus 18 squared would have to be equal to 24 squared, but when you add them together, it is 468, not 576, so it is not a right triangle. So if we're just given the measurements, and we're not even given the triangle, we can't even make a guess as to whether or not we think it looks like a right triangle or not. We just have to rely on the math. Knowing that the longest side length would be C, okay, that makes this 28 equal to C, and then this could be A and B. So 21 squared plus 20 squared would be equal to 28 squared. So 441 plus 400 equals, in this case, 28 squared is 784. When you add 441 and 400, you get 841. It does not equal 784. Therefore, the answer is no, not a right triangle. Okay. Again, looking for, in number 2, the longest side would be C. The other two can be A and B. 1 squared plus 0.75 squared must be equal to 1.25 squared. 1 plus, and then when you square 75, you get 0.5625. And this, when you square it, you get 1.5625. And so, therefore, when you add together, and they are equal, the answer is yes. This would form a right triangle. Another key idea in this lesson is the distance formula. The distance d between any 2 points, x1 and y1 and x2, y2, is given by this formula. So think about this, guys. We talked about this idea, if we look at the ratio of the change in y over the change in x, this is a lot like that, like the slope formula. We could tell the slope of the line. But if we think of it as right here in this picture, we're wanting the distance d, and we have 2 points, one right here and one right here, we could form a right triangle. Okay, forming a right triangle. Then you measure the distance here. The change in y becomes one leg. The change in x becomes another leg. So now we're using that slope formula in a little different way. So it's just like taking a squared plus b squared to be equal to c squared. In this case, c squared would be equal here. So don't let it get too confusing or scary. It's just saying that, the change in x now becomes leg A, the change in y becomes leg B, and when you find the distance between those 2 points, x1 and x2, that's the distance or the length of A that you would be squaring. So it just has a lot more variables, but it really means the same thing. And when you square that, and then you add to that the square of the distance, which would be equivalent to leg B, then you have to take the square root of all that to get the length of C. So we'll be working with that. So here's the points, 1, 5, and -4, -2. Let x1, y1 be 1, 5. x2, y2 be -4, -2. Putting it into the formula, you would be calculating the difference between the two x coordinates, -1 minus 2, and for the y coordinates, -2 minus 5. So you take the square of -5 and the square of -7, add them together to get the 74. When you take the square root of 74, it's not a perfect square, so you do not have to evaluate it or round it or estimate it, okay? Only evaluate perfect squares. So let's try a couple. I will write the distance formula up here. Okay, so you big long square root symbol, and then you have x2 minus x1 squared plus y2 minus y1 squared. Again, this could be x1, y1, x2, y2 if you need help on figuring out where they go. So for 3, the square root of, you would put in here 4 minus 0 squared plus, sorry, my y looks a little bit sloppy here, so I didn't want to confuse you. 5 minus 0 squared. So this is 4 squared plus 5 squared when you take the difference inside the parentheses. So 16 plus 25 in this case is going to be equal to the square root of 41. The square root of 41 is not a perfect square, so we'll just go ahead and leave that as the answer. For 4, you would have 9 minus 7 squared plus 6 minus the -3 squared. Remember, this double negative means to add. So we get 2 squared, and 6 minus -3 is like 6 plus 3, or 9 squared. 4 plus 81 adds up to the square root of 85. Again, not a perfect square. In number 5, -5 minus the -2, which would be -5 plus 2, so that would be a -3 squared. And then we're going to have 1 minus the -3, or 1 plus 3. So here we have -3 squared plus 4 squared, 9 plus 16, which equals the square root of 25. So we can simplify that down to 5 as the distance between.
Okay, for this example, it says a football coach designs a passing play in which a receiver runs down the field, makes a 90-degree turn, and runs to the corner of the end zone. If the receiver starts at 40, 40, turns at 20, 10, and then stops at 80, -30, did the receiver run the play as designed? Basically, we want to know, did they make that 90-degree turn? Did it form a right triangle? So we can do some calculations, basically determining the distance between these points. So let's start by listing what our points are. We have, let's see here, 40. Oh, I was supposed to change. Sorry. I'm going to erase this because I want to change color here on you. Okay, 40. We have 20 and 10. And finally, we have 80 and negative 30. So I kind of gave our x and our y different colors here because we're going to use the distance formula. And the distance formula is going to take, the distance is going to be the square root of, and then we're going to have x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So it's kind of like the Pythagorean theorem in a way. It's kind of like a squared plus b squared, and then add them together and take the square root to get like the diagonal or the distance between them or the length c. So we're going to be calculating out 3 different sides, okay? So let's see what the side length difference is here. So we'll do distance is, and then we're going to take our 20 minus 40 quantity squared plus 10 minus 40 quantity squared, which basically gives us, and we're going to just do like the absolute value here. I guess it doesn't matter. We take negative 20 squared plus negative 30 squared. We're going to get the square root of 1300. And I just will leave it like that for just a minute. Now we want to do the same for the other sides. Let's try between these two sides and let's see what the length of those sides would be, or the distance between them, I should say. So with the x, change in x, we're going to have 80 minus 20, right? The reds, 80 minus 20, quantity squared. We'll have negative 30 minus 10, quantity squared. Make sure this goes all the way across. Remember, I'm not trying to shortchange this here. So that's like taking the square root of, the difference here is 60 squared plus, and then we have negative 40 squared, which basically gives us, if you crunch, 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 square root of 5,200. And I'm not evaluating it yet, okay? Finally, we need to do this side and this side to connect and close that triangle. So we will take the distance of, and now we're going to take 80 minus the 40 plus the negative 30 minus the 40 quantity squared. This is giving us the, we'll have 40 squared here, and this will give us negative 70. And we're going to square that, add those numbers together, and we will get the square root of 6,500. Now, these 3 are the side lengths of our triangle. What we know about the Pythagorean theorem is that the hypotenuse is the longest side, which would make this the hypotenuse, okay? So this is A, this is B, B, or A, B really does not matter. The legs, right? Because addition is commutative. So we have this quantity, the square root of 1,300. I'm doing a lot less work by not evaluating or simplifying these numbers. Plus the square root of the 5,200 squared has to equal, and all we're doing is checking to see if it does, right? Because we want to know, did he run the correct play? It must equal the square root of 6,500 squared. Well, when we do this, it's like an inverse operation. So we get 1,300 plus 5,200 equal to 6,500. Believe it or not, it is equal to 6,500. Since they are equal, it makes it a true statement, which means that yes, The receiver ran the play as designed. We know that because you can use the Pythagorean theorem to prove it. It only works on right triangles, which have a 90-degree angle, which means he made a 90-degree turn. Oops, didn't mean to actually cross it out. I was trying to highlight it. Okay, it's a lot of information, so if you need to pause it and copy that down, go ahead and do that. And we are at the vocabulary and concept check. Remember, you're writing incomplete sentences, and let me know which one you are solving. And then have a great night. And I will see you in class tomorrow.